Fundamentals of Organic Chemistry. In Fundamentals of Organic Chemistry lesson, already we have seen so many videos on this topic. In this video, what we are going to see is detection of elements. How to detect the elements present in an organic compound along with carbon and hydrogen. Preparation of sodium fusion extract with using sodium fusion extract, how to identify nitrogen, sulfur, halogen present in an organic compound, and also test for phosphorus. How to detect elements present in an organic compound? The first one is detection of carbon and hydrogen in an organic compound. To identify, to detect the carbon hydrogen present in organic compound, it is heated with copper oxide in a bent delivery tube. If carbon present in an organic compound reacts with the copper oxide in it forming carbon dioxide and copper, it reduces copper oxide into copper, it itself oxidizes to carbon dioxide, and also hydrogen reduces copper oxide into copper, itself oxidizes to water. The evolving carbon dioxide reaches the lime water and turns lime water milky. From the change of the lime water milky shows the presence of carbon dioxide in an organic compound. Similarly, the hydrogen present in an organic compound giving the water vapor, it condensed into water molecule. The suspended water molecule changes the colorless copper sulfate into colored copper sulfate. Because of the evolving water molecule reaches the copper sulfate kept in the side of the bent tube and it changes its color. From the change of the color from colorless to colored copper sulfate with the water of hydration and the turning of lime water milky shows the presence of carbon and hydrogen in an organic compound. The next one is to identify nitrogen, sulfur, halogen in an organic compound. We have to prepare sodium fusion extract or lassigenous sodium fusion test. So why there is a need to prepare sodium fusion test is the nitrogen, sulfur, halogen present in an organic compound converted into the ionizable sodium salt. Thereby it is easy to identify those elements in that form. So for that the sodium metal is taken in a fusion test tube, easily breakable sodium test tube. On melting the stage of the sodium metal, we have to add the organic compound to be identified in that ignition tube and we have to heat the test tube to the red hot condition. At red hot condition, we have to change that ignition tube into the china dish containing water. We have to blend that test tube into that water taken in a china dish and break the bottom of the tube by striking against that dish. And boil the content of the dish for about 10 minutes. Then after that we have to filter that solution. This extract is called sodium fusion extract where nitrogen, sulfur, halogen is present in the form of the ionizable form or ionic form as a salt of sodium. So by using this we can identify easily the nitrogen, sulfur or halogen present in an organic compound. Test for nitrogen. The nitrogen present in an organic compound in the sodium fusion extract as sodium cyanide. We have to take the sodium fusion extract in a test tube. To that we have to add ferrous sulfate, corn HCl and ferric ion. The resultant color is Russian blue or green precipitate of ferric ferrocyanide. So to the sodium fusion extract we have to add the reagent. The end result is Russian blue of ferric ferrocyanide. What is the reaction takes place? Sodium reacts with the carbon, nitrogen, it forms sodium cyanide. So the nitrogen identification, sodium fusion extract contains sodium cyanide. To that we are adding ferrous sulfide. The ferrous sulfate reacts with the sodium hydroxide. The sodium hydroxide comes from the sodium metal on heating and it forms a green color precipitate of ferric hydroxide. To dissolve the ferric hydroxide precipitate, we have to add corn HCl. Then next the sodium cyanide reacts with the ferric hydroxide and it forms sodium ferrocyanide coordination complex. To that we have to add ferric ion. Sodium ferrocyanide reacts with the ferric chloride, ferric ion. The sodium replaced by ferric, it forms ferric ferrocyanide. Russian blue color or green precipitate shows the presence of nitrogen in an organic compound. So this is the test for nitrogen. For example, if an organic compound contains nitrogen along with the sulfur, what is the test? So for that we have to add ferric chloride to the sodium fusion extract. If nitrogen along with the sulfur present in the sodium fusion extract means it is in the form of sodium fusion extract, it is in the form of sodium sulfocyanide. To that, if you add ferric chloride means the sodium sulfocyanide reacts with the ferric chloride, it forms ferric sulfocyanide, FeCNS thrice plus sodium chloride. So, the formation of blood red color ferric sulfocyanide shows the formation of red precipitate, shows the presence of nitrogen along with the sulfur in an organic compound. We have to read and memorize these equations. Test for sulfur, how to identify the presence of sulfur in an organic compound in the lacigenous extract. You have to take this lacigenous sodium fusion extract, to that you have to add sodium nitroprusside. It formed deep violet purple coloration. So, what is that? So, purple violet coloration is Na4FeCN5 times NOS. Sodium nitroprusside, when added with the sodium sulphide, it forms a complex compound like this. So, this only gives the purple deep violet color, shows the presence of sulfur. Another portion of the lacigenous extract to identify sulfur, it is added with acetic acid and lead acetate. So, the sodium fusion extract containing the sulfur in the form of sodium sulphate reacts with the lead acetate. The sulfur and lead combines, forming lead sulphide black precipitate. So, the formation of black precipitate lead sulphide shows the presence of sulfur in an organic compound. So, these are all the two tests: sodium nitroprusside violet coloration and the addition of acetic acid lead acetate black precipitate shows the presence of sulfur in an organic compound. Another test to identify sulfur is the oxidation test, where organic substance directly heated with potassium nitrate and sodium carbonate, thereby the sodium carbonate and potassium nitrate reacts with the sulfur present in an organic compound, forming sodium sulphate and carbon dioxide. To that, we have to add acetified with hydrochloric acid. It is extracted with water and acetified with hydrochloric acid, and it is treated with the barium chloride solution. So, actually the sulfur in the form of sulphate salt easily reacts with the barium chloride. So, barium plus sulphate, it forms double decomposition reaction, sodium chloride and barium sulphate. So, it forms the white precipitate of barium sulphate. It is insoluble in corn HCl. The formation of white precipitate of barium sulphate shows the presence of sulfur in an organic compound. It is oxidation test. The next one is test for halogen, lacigenous test of identifying halogen. For that, the lacigenous filtrate is treated with dilute nitric acid and silver nitrate solution. By adding dilute nitric acid and silver nitrate solution, if when the organic compound containing a halogen chlorine means it forms curdy white precipitate of silver chloride, shows the presence of chlorine. On the other hand, it forms the pearl yellow precipitate by the addition of dilute nitric acid and silver nitrate mean it shows the presence of bromine. Otherwise, if it forms the yellow precipitate of silver iodide means it shows the presence of iodine. So, for chlorine, white precipitate soluble in ammonia solution. For bromine, pale yellow sparingly soluble in ammonia solution. For iodine, it is insoluble in ammonia solution. Why it is silver chloride? Why it is pale yellow? Why it is white? Why it is white, pale yellow, yellow precipitate is the pale color is white precipitate is silver chloride. Actually, the yellow precipitate is pale yellow precipitate is silver bromide. The yellow precipitate is silver iodide. The halogen present in an organic compound will preparation of lacigenous extract combines it to form sodium halide, sodium chloride, sodium bromide, sodium iodide. To that, if you add silver nitrate means it forming corresponding silver salt, silver chloride, silver bromide, silver iodide. That is NaCl plus AgNO3, it form AgCl plus sodium nitrate. Sometime there may be a presence of nitrogen and sulfur in an organic compound. It may interfere with the identification of halogen. So, for example, if you add silver nitrate means it may form silver cyanide and silver sulphide as a black precipitate, white precipitate during the analysis of halogen. So, for that, to remove the nitrogen and sulfur in an organic compound while the analysis of halogen, it must be treated with nitric acid, thereby it removes nitrogen as hydrogen cyanide, sulfur as a hydrogen sulphide. So, the elimination of nitrogen and sulfur during the analysis of halogen by heating with nitric acid. The last one is test for phosphorus. The compound to be tested with organic compound to be tested with phosphorus is heated with sodium carbonate and potassium nitrate. Phosphorus present in an organic compound is oxidized to sodium phosphate. It is extracted with water by dissolving in water, boiled with corn nitric acid and ammonium molybdate. It gives the yellow coloration, canary yellow coloration or yellow precipitate shows the presence of phosphorus. This one is test for phosphorus. So, test for phosphorus, elimination of nitrogen and sulfur, while the analysis of halogen, Lassiggenus test of identifying halogen, oxidation test for identifying sulfur, white precipitate of barium sulfate. When the test for sulfur, sodium nitroprusside violet coloration, so acetic acid acetate, lead acetate black color. Now, identification of nitrogen and sulfur along with them carbon, the ferric ferrocyanide blood red coloration, and identification of nitrogen present in an organic compound Prussian blue ferric ferrocyanide, and the preparation of sodium fusion extract, and this one is the turning of lime water milky presence of carbon, and the hydrated copper sulfate formation of blue color. Hydrate copper sulfate conversion of colorless into blue color shows the identification of carbon, hydrogen, nitrogen, sulfur, phosphorus, halogen present in an organic compound. Subscribe for more videos. Thank you.